Okay. Now let's go ahead and look at the whole thing here. I've written some stuff up here. We'll get to it in a minute. But we have a graph that points negative C, B. Okay. Now, what you do when you have a graph and a point like this, and you're doing an estimate, is you draw yourself a graph that looks like the one that you're given. Okay. And you got a point here. Okay, now in my case, okay, my A numbers are my ABC numbers are 5, 7, and 9. Okay, so that means that this point, instead of negative CB, is now negative 9, 7. Now, for your numbers, it's going to be different, but it's negative 9, 7. Now, the first thing we do when we know the coordinates of a point, and of course, we got to have the graph before we can do this, right? So we sketch the graph, and then we sketch the vertical line and label that line. That's x equals 9. Okay. Now, if you just drew the line, and didn't label it x equals 9, that's okay as long as you label this point then 9. It's better to write x equals 9 because it's important to know what the line x equals 9 looks like, and that reinforces it. So label everything you do. Okay. Now, I can label this whole line y equals 7. Now, if you go back and look at the videos from last time, you don't really need to if you get this, but if you were to look at the videos, you'd see that that's exactly what I did. Okay. So it's always not a bad idea to take a look at the videos. Of course, you got a lot to do. You might not always have time. So, take the best notes you can. If I write this down, you need to write this down because I'm writing it down for a reason, which is to emphasize what the line y equals 7 means, what the line x equals 9 means, and what all that has to do with these questions. These are the main questions you ask of any graph. Asking you to estimate it rather than do it using algebra. Okay. Because I want you to see what's going on. If you just dive into the algebra, you lose track of what anything means, unless you already know what it means. So we're starting with what these things mean. Okay, so you got y equals 7 here. Okay. And that's a good start. Now, of course, we want to put 7 up here. So I say then you label the axis. Well, if you can evenly divide this interval into 9 parts, or even do halfway decently, and you maybe can. Okay, go ahead and do it. Okay, if you divide this interval into 7 parts, okay. Now, if this number's 73 and this number's 598, you don't want to be making all those marks. Okay, especially about 598. 73 wouldn't take all that long, but what are the chances that you would get it right? What are the chances you would start here with what you think is 1 out of 73 and make all your marks the same and come out on the 73rd number? Okay, you wouldn't. So if you want to estimate information from a graph that you think means something, it's best maybe to start out with numbers like 2, 4, 8, 16, 32. Just start with 2 and keep multiplying by 2 and get a number that's somewhere in the neighborhood of 9. Maybe a little more than 9, maybe a little less than 9. So I would say if 9's here, it's pretty reasonable that 8 might be here. And then 4 would be halfway between here and here, and 2. So here we've got 8, and then 4, and then 2, and then here'd be 6. And now we've got a pretty nice even scale. It goes all the way out to 8. And of course, we based that with 9 being there, so we're pretty close. Then we could do 8 more here. We'd say, okay, well, 16 ought to be about here. And we divide that in half, and we get the number halfway between here, 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 here. And we're going to need all the details, but you real quickly get a scale that way. Okay. And 7's up here. Well, I'm gonna pick an 8 again. So I'm gonna put 8 here, which means 4 would be about halfway down here. And 2 would be here, and 1 would be here, 3 would be here, 6 would be here, 7's where it is. Okay, and right there is a pretty good scale. It's gonna allow me to make estimates. Now, again, you can figure out how to scale it. That's kind of the way I recommend. One problem with open math is it never makes you actually think about the scale. It just gives you a graph and has a scale on it already. Okay, you should think a little deeper about the graph. You'll be better at thinking about the graphs if you see what's going on. You'll see what's going on if you follow this procedure. At least I think so. Now, if 16 is here, then it ought to go out to about here. And actually, these are negative numbers, -9, -8, -4, -2, -16, and so forth. I was a little careless when I wrote x equals 9, which is clearly not the case because over on this side. Okay, so if we got 16 here, we divide that in half. I'm going to say that 8 goes about here. It might be accurate, it might not. But then I just divide things up. Keep just dividing intervals in half, because I'll always get down to a unit of 1. And I went over this, did it in a little more detail last time, but there is a perfectly good scale. Now you're probably going to need some negative numbers. So if you got 8 up here, I will come down here and say, okay, here's -8. So here's -4, -2, -6, and then the numbers in between. Got a good scale for negative numbers, negative y-axis. Okay, so we got it all scaled. Now, question is, what's y when x equals -c? Okay. Well, I'm going to write out my solution. I didn't really give myself enough room here. So I'm going to have to kind of spill over here. So I can say over here and make the statement. If x equals -c, which is -7, you know what? No, c is -9, sorry. If x equals -9, I thought I'd done something wrong there. I was looking wrong here. If x equals -9, y equals what? Well, if x is -9, we come up here and we see that y equals 7. And that's no surprise because I already said when x is -9, y is 7. Okay, so it comes back to the original point. I wanted to start you off with a couple of easy questions, okay? Y equals 7. And that's from the graph. Okay. What's x when y equals b? Well, b equals 7. And you can make the statement. If y equals 7, what does x equal? Well, the first thing you're going to say is, well, if y is 7, well, we started out with the point -9, so x could be -9. But also, there are 3 points for y equals 7. It's very clear, if you got this line, y equals 7 here, that it intersects the graph in 3 points. Okay, so okay, well, here's another point where x equals 7. I'm going to say it's about, or for y equals 7, say I said it wrong. When y equals 7, x is about 2. Now, my estimate here would be about 2.17384. Believe me? Good. Tell me what I want to hear. Don't tell me what you really think. Okay. So this point is about I'm gonna estimate negative 2.27. Okay, because it's a little past 2. I'm gonna say -9 or negative 2.2, or there's one out here. Okay, well, now in some of your graphs, the number here was so big it went beyond the end of your graph. You couldn't answer the question. Okay, so you could say it's out of the domain. Okay, and we'll see what domain and range are, because they come right in. Now, so we can estimate, you know, how far is that? That looks like about 4 units. Okay. I'm gonna say this point looks like it's maybe 27. Okay. So all of a sudden, there's one obvious answer to this. It comes from the initial point, but now we see that there are 3 points, 3 x values that make y 7. Okay. Now, what's y when x equals c? Well, and also, see how I'm writing these out? It'd be very helpful if you would write short statements like this. Because when you just put an answer down, and the answer's not right, I don't know what you're thinking. Okay. If the answer's right, I can kind of recognize it if it's reasonable, you know, especially, you know, here in class and stuff, and say, yeah, I believe that's right. But I'd see it faster if you wrote down the statement. Now, it's not a big class. I've got time to spare, beat my head against things until I really see them. Okay. But 2 things. It makes it easier for anybody to see what you're doing if you write out a statement. And it's important to communicate. One of the things that we're supposed to be teaching here is communication. Okay, it's not the official goal of this course, it's an overall goal of college. So we're trying to address communication, and this is an aspect of communication. Write down what you mean. It's an art. It takes a lifetime to get any good at it. So I hope I live a lot longer. So I can have time to get good at it. Okay. You write out a statement like this or similar to it that really defines what you're doing. You're going to learn it better because it focuses you on what you just did. So instead of just doing it and kind of vaguely understand it and writing down the right answer that you're going to forget after 2 days, whether you more likely to forget after 2 days, you're probably going to remember, but you write down the statement, it locks it in for you. Okay, so for many reasons, we want to write out, we want to communicate what we're doing. To me, that's kind of important. But to yourself, that's what's really important. Communicate it to yourself. Okay, so think about that. Think about how you would do it. We'll be working on that. What's y when x equals c? Okay. Well, c is 9, so we come out here to 9. We write to line x equals 9, and we observe the coordinates of the point. Bring this point over here, and I estimate this is the point. -0.7. So that's here. And maybe I ought to make the point blue. Make my line -0.7 blue. And make these projection lines blue. Okay. So we can easily identify it. A lot of you got really good estimates on that one. So we just got y equals, I'll say approximately equals negative 0.7. Now, soon enough, you'll have formulas in algebra to solve, to figure out the answers to these questions, okay? Right now, we're just doing it by estimates. We know what it is we're doing when we do the algebra. And that helps you understand what algebra to do when you need to, okay? Okay, well, what's x when y equals 0? Now, these are important points. We call these the zeros of the function. Okay. I'll write that down. So we got one here. We got one here. We got one here, because clearly y is 0 at every point on the x-axis. The curve intersects the x-axis at these points. So the points on the curve where y equals 0 are these. Okay, so this is about negative 14.5. Let's see, things are getting a little cluttered. So I'm going to draw this. This is x approximately equal to negative 14.5. That's one of them. Over here, there's 8, 7, 6. Looks like about 6.6. Or what in the world is that? That's about 10. That's not 10. That's not x equals 9 either. 8's all the way over here. I must have lost my mind when I called that 9. And I was looking at that like it was 8. That's 12. I got to fix that in a minute. I don't know what I was seeing. I didn't see it right. Anyhow, we'll fix that in a minute. Okay. This is 16, 15, 14.1. Now my graph is getting a little cluttered up. You understand why I tell you to draw a big graph, right? You're going to label all this and you draw a little tiny graph. You're going to have micro instruments to label it, and I'm not going to be able to read it. Make me get out a magnifying glass, I'm going to penalize you half the time. Okay, I won't do that. Okay, so those points give us this. And if I'd have left myself more room down here, I could have labeled these points. But, I can label this one. And I could probably label this one safely. And then, yeah, I can get this one down. There's 6.6. So those are my zeros, and they correspond to this statement, which tells me completely that you not only have marked the points, you've answered the question. Okay. Now let me fix what I did over here. I wasn't looking at the graph very clearly. I wasn't being real careful. It's not 9, that's 13. So this point should be 13 negative 7. Okay. Makes sense? Well, now we get down to what is f of a. Okay. We're gonna need a little more room. I'm not gonna try to answer it down here, but you see I've got answers to this question, this question, this question, and this question. And these questions are no different than these. If you know that y equals f of x. So if I ask you, what's f of a, I'm asking you for a y value when x equals a. Okay, so well, let's go ahead and use my the a value. My a value is 5. Okay, y equals f of x. So x equals 5. And f of 5 is a y value because y is an f of x. F of 5 is the y value when x equals 5. Okay, so f of 5 is a y value when x equals 5. Okay, so well, if x equals 5, y equals what? Well, this is where the graph is starting to get a little bit cluttered. If x is 5, well, here's 1, 2, 3, 4, 5. And here's the point where x equals 5. And you know, my projection line's a little off, probably should really be 3. But I'll just take what I drew. It's about 4.3. Okay. Now it's getting a little hard to label. So I'm just going to have to say, okay. X equals 5, y is approximately I've got this in red. So it corresponds to these projection lines, and I don't have room because I should have made a much bigger graph. Cover the wall. Okay. Now, solve f of x equals a. In my case, that's f of x equals 5. Okay, I'm going to do this in different colors so we can see what it is in the graph. Okay, so we want to find f of x is a y value. This is a y value. And I wrote it down exactly wrong. The x value. No, you see this, write it out wrong. The x value when y equals 5. F of x is a y value. So the y value is 5. We're trying to find x, which we don't know. Well, now that we understand, or at least can write down the statement of what this solution means, we can say, okay, here's x, here's y equals 5. Here's the line. Y equals 5. We've got 3 points for this line intersects the graph. Okay. So we can say and I'm gonna, right, there are many ways to write these out. Okay, so what are the coordinates at this point? Looks like it's about, let's see, there's 8, 9, 10, 11. So in my graph, it looks like negative 11, 5. Here, this looks like 1, 2, 3, 4.2. And out here, that's 16, that's 20, 18, 18.5. Bad looking H, I made it look worse. Okay. The solutions. Are x equals negative 11, approximately 4.2, 18.5. Okay, we're kind of oriented to this graph. You got your speed miles per hour versus your time in hours. Now this is what y equals. I'm going to call it V. Let's see. Speed's velocity. As long as your speed's positive, your velocity is the same as your speed. Okay. And you can't go to negative speed. And so your velocity is always positive. Now you go backwards. So in that sense, yeah, you can. That means if you're driving from Roanoke down, you're always going at a negative speed because the mile markers keep going down. But you can't have a negative speed, you have a negative velocity. Okay, well, actually that is recorded. Okay, it was worth recording. There's a distinction between speed and velocity, so we can talk about it. Take that for what it's worth. In physics, it's worth a lot. Okay. Now, what I want to know is estimate your time without even putting the scale on this thing. Estimate the time when you're speeding up most quickly. Look at the graph and see if you can figure out where you're speeding up most quickly. Okay, we've got a good eye on this. Everybody's on the same page. But what I'm asking is, where's the speed increasing most rapidly? So I ran my finger along the graph and say, oh, right about there. Yeah, it's steepest right about there. And that's when your speed is going up most quickly. Okay, where's the speed neither increasing nor decreasing, go along, people say, yeah, it's not worth nothing. Yeah, nothing. And then it's decreasing probably. Maybe most quickly right here. So you would implement the graph. Okay, so. This is a tangent line. It's supposed to actually touch the graph. Let me much off this. Okay. So. That shows you how quickly it's increasing. There's no other point on the graph I could draw a steeper line that is tangent to the graph. Tangent means touches the graph just at that point. Okay. If I make it a little steeper, it's going to go through the graph. A little less steep, it's going to go through the graph back here. Up here. Tangent line horizontal. Okay. So. Up most quickly here. Bigger, steepest tangent line. Okay. Say the unchanging speed is at this point. There's a horizontal tangent line. Okay. Now. Between, I gotta do this kind of quick to go out of time, but. You can see this. Okay, is your speed changing? Is it increasing or decreasing between this point and this point? Well, it's decreasing now, this one. You understand that. Okay, so. Actually, about 3.5 in this line. X is about 4.2 on this line. Okay. What's that mean? But I drag it out. I'm just going to tell you. You want to maybe review, especially this part of the video. Okay. And it's not X anymore, it's T. T changes by 4.2 minus 3.5, which is 0.7. Okay, meaning 0.7 hours. Now up here. We have to. Throw these way over here, so I'm going to have to label it way over here. And then leave myself enough room. Okay, what's your speed here? Pretty close to 80 miles an hour, right? So. Y is about 7.9 on this line. And let's say that's 80. I'm going to say 40 is about here, so 60 is about here. So. It's not 7.9, it's 79. Yeah, I'm going to say it's about 58 here. Okay. So. Y changes from 79 to 58. Now, what's the change from 79 to 58? Negative, isn't it? as you're going down, okay? So. Page is -21. Meaning. -21 miles per hour. Okay, now let's. Go away from this for just a second. If your speed changes by 10 miles an hour in 2 seconds, which you could easily do, you put on your brakes a little bit, right? Speed changes by 10 miles an hour in 2 seconds. At what rate the speed change? Can you give me a number with your fingers? How quickly was your speed changing? Well, yeah, we'll talk a minute, but I gotta let you out of here. Okay, so. There are more words I should put in this. I'm gonna say the average rate of change is. -21 over 0.7, meaning -21 miles an hour over 0.7 seconds. Of course. Not 0.7 seconds, 0.7 hours, it's -30 miles per hour. That's how quickly we lose the speed on the average. There's a picture that goes with this that I'll withdraw quickly because it's really important. This triangle here. This side is going to be -21 miles per hour. This side is going to be 0.7 hours. And the slope of this thing is rise divided by run. The rise is -21.7 is the run. And I put the -30 here. Put a box around it.